welcome. Today we're going to be talking about L'Hopital's rule. And we're going to review an example from Calculus 1. This example is to compute this limit as x tends towards infinity of x over x squared plus 1. And let's make that x squared over x squared plus 1. Okay. So from Calculus 1, we were told to do this. So that is to multiply top and bottom by 1 over x squared. And 1 over x squared is the highest power in the denominator. So if we do that, well, we'll multiply this times the numerator, that'll give us 1. Then we'll have to multiply this times this, and this times this. Well, we're going to get 1 plus 1 over x squared. Then, hey, when x tends towards infinity, this is going to limit to 1 over 1 plus 0. The limit's 1. Okay. Now, here's going to be L'Hopital's rule approach. And this applies for things of this form. So it applies for the form infinity over infinity, and we'll do plus or minus 0 over 0. So these are the important forms. If we have one of these two, we can use L'Hopital's rule. So if we're asking what's the form of this problem, well, we have this limit as x tends towards infinity of x squared over x squared plus 1. And if we were to, in a way, plug in the limit to the numerator and denominator, we'd have infinity over infinity in the denominator. Okay, remember, infinity squared is still infinity. Infinity squared plus 1 is still infinity. So since we have this form, we can go ahead and proceed to do this L'Hopital's method. So this would be the answer using L'Hopital's, is we'll compute this limit as x tends towards infinity of x squared over x squared plus 1. Now, L'Hopital, which will be applied right here, it says when we have one of these two forms, go ahead and differentiate the numerator and differentiate the denominator. If we go ahead and do that, hey, derivative of the top is 2x, derivative of the bottom is also 2x, and this is going to be 1. Okay? And that's exactly the same answer we got before. L'Hopital's rule, in a sense, is comparing the rates that the numerator and denominator go to infinity. Okay. Let's try another example. Okay. And let's do this limit. Limit as x goes towards 1 of ln of x divided by x minus 1. If we ask for the form here, well, that would be like plugging in the value into the numerator and denominator. Ln of 1 is 0. The denominator is also 0, so it has the form of 0 over 0. That means go ahead and use L'Hopital. We have the green light. Okay, so we use L'Hopital. We take the limit as x goes to 1 of the derivative of ln of x divided by the derivative of x minus 1. Well, that gives us the limit as x goes to 1. Derivative of the top is 1 over x. Derivative at the bottom is 1. This simplifies to just be the limit as x goes to 1 of 1 over x, which is 1. Great. Okay, so let's try one more example. This example is going to be this limit as x tends to infinity of ln of 3x divided by square root of 3x. Okay, well, the first thing to do is to ask if you can use L'Hopital's rule. In this case, that amounts to asking for the form. The ln of 3x as x tends towards infinity is infinity. And likewise for the denominator, that's also infinity. So we go ahead, we use L'Hopital, and we take the derivative of the top divided by the derivative of the bottom, and I'm going to rewrite this as 3x to the 1/2 power. Okay, so we differentiate the top. That's going to be 1 over 3x multiplied by 3. Okay, and I had to use the chain rule for the derivative of the top. Okay, for the bottom, I'm again going to have to use the chain rule. That'll be 1/2 times by 3x to the minus 1/2. Then we need to multiply by the derivative of the inside. That's 3. Great. If we simplify this, we're going to get 1 over x divided by 3/2 times by 1 over root of 3x. Great. So we have a fraction divided by a fraction. We invert and multiply. So we'll get 1 over x times 2 times root 3x divided by 3. Okay. I think that this will simplify to this limit as x goes to infinity of 2/3 multiplied by root 3 times by root x over x. And by the way, 3 can be written as root 3 squared. So I can cancel that square there. And then this will simplify one more time, just doing algebra, as 2 over root 3 times by 1 over square root of x. That's how the last term simplifies to. Now as that goes to infinity, this limits to 0. Okay, so our final answer is 0 in this case. Okay. Well, that's the examples I want to go over. There are other forms of L'Hopital's rule that I'll be going over in different videos. Thank you.